I'm in Ferris, and I'm doing my deeper chemistry connections presentation. I'm doing it on sewage leaks, and but it's mostly focused on sewage as a greater whole. For the first topic, I'm doing pipe corrosion. The general topic for this was, of course, pipe failures, leakages, and blockages. I'm not covering blockages because they're not really chemistry related. People just flush stuff that isn't compatible, and tree roots sometimes grow into pipes, blocking them. But the larger cause of pipe failures, actually, and the chemistry related one would, of course, be pipe corrosion. Pipe corrosion is a large cause of sewage spills. The process itself is a galvanic process by which metals deteriorate through oxidation, usually but not always to their oxides. Older and much more problematic sewage lines are typically constructed from iron, which, of all the various metals subject to corrosion, is by far the most commercially important and relevant for sewage lines, of course. I think there's something like $100 billion in pipe corrosion damage each year in the United States, actually. Furthermore, when iron corrodes, it forms a red-brown hydrated metal oxide commonly known as rust. Rust does not provide a tight protective film, which leads to leakage and breakage, causing sewage spills. Pipe corrosion. If iron is in contact with a more corrosion-resistant metal, such as, this is also an interesting fact regarding corrosion, when iron is in contact with a more corrosion, such as tin, copper, or lead, the other metal can act as a large cathode that increases the rate of the reduction of oxygen. Because the reduction of oxygen is coupled to the oxidation of iron, this can actually result in a dramatic increase at the rate of which iron is oxidized at the anode. Galvanic corrosion is likely to occur whenever two dissimilar metals are connected directly, which, of course, allows the electrons to be transferred from one to the other. Some common solutions to actually address pipe corrosion. One common method of addressing pipe corrosion is actually just replacing the pipes with a material that won't corrode. Big surprise. Plastic sewer lining piping is like the modern material they use nowadays. And obviously, this is used because plastic is a non reactive metal, and the main condition for rust is it should react with water and oxygen, and plastic does not, so it does not rust. Another common workaround used to prevent the corrosion of iron is applying a protective coating of another metal that is more difficult to oxidize to the iron. Faucets in some external parts of automobiles sometimes, for example, are coated with a thin layer of chromium using an electrolyte process. Basically, protective coatings consist of a second metal that's more difficult to oxidize than the metal being protected. So, the protected one doesn't oxidize. Topic 2 consists of sewage composition and interactions. I'll be going over sewage itself, for greater clarity to understand why it's so dangerous, why it must be addressed properly, and all such fun details. Chemically, sewage consists of approximately 99% water and 1% inorganic and organic matter suspended in soluble forms. Lignoli, cellular proteins, fats, various inorganic particulate matter exists in a suspended state, whereas sugars, fatty acids, alcohols, amino acids, and inorganic ions constitute the soluble forms of the sewage solution composition. Next slide. Further composition details. Oxidation consumption values are extremely high in sewage. Sewage organic matter undergoes anaerobic or partial decomposition, which results in the production of obnoxious gases due to the anoxic conditions, the lack of oxygen. Despite being toxic, these gases react with the water and produce acids, besides being toxic. Production of all these acids in very large quantities makes the sewage more acidic, obviously, therefore making it unfit for supporting life activities. Also, there's tons of heavy metals generally present in sewage, which once more bodes bad for life. The danger of all these conditions, of the anoxic conditions, high acidity, high heavy metal concentration, and the reduced photosynthesis rate due to poor illumination, causes death of oxygen-dependent organisms such as aerobic microorganisms, plants, and animals in sewage. This is the reason why sewage is dominated by organisms capable of growing in anaerobic environments. Interesting fact. Common disposal and repercussions. Sewage disposal has become of prime importance nowadays as it brings undesirable and harmful effects on living beings. Untreated or inadequately treated, sewage is generally disposed of into natural water reservoirs that is poured in without taking any consideration of the repercussions of such. This isn't a good idea, obviously, because it's working under the false assumption that water reservoirs are always going to be large enough to dilute all the sewage to prevent any hazards or risks, which is just a very bad idea because here we go, the repercussions. Frequent dissemination, poor disposal of sewage or no disposal of sewage leads to frequent dissemination of waterborne diseases, causing microorganisms in large numbers. A depiction of dissolved oxygen in water, leading to anoxic conditions, which obviously kills the aquatic life that needs oxygen. Creation of offensive, poor odors and debris leads to decrease in quality of life and detracts from property value around locations affected by such. Also, it increases danger of swimming in water and diminishes the value of water for other such recreational purposes. Topic 3 is treating sewage. Sewage treatment is the process of removing the impurities mixed in the water so that the remaining water can be safely returned to surface waters, rivers, bays, and oceans, and become part of the natural water cycle once more. Wastewater goes through 3 treatment processes in order to separate substances out of the mixture in order to obtain water in its purest form. So it can be, returned to the natural stuff. Some substances are soluble and others are insoluble. There's a lot of different procedures to perform to remove each substance. So regarding the substances, the procedures, chemists employ different methods to separate solutions into their components. Wastewater is primarily treated in 3 different significant stages: primary, secondary, and tertiary treatments. So starting off, we got the primary treatment. The first stage of wastewater treatment is known as the preliminary screening. The screening process removes insoluble particles. The smaller particles and liquid pollutants move on to the primary sedimentation tank. Smaller particles such as sand and suspended insoluble solids settle out due to gravity. And minuscule liquids in water like grease and oils float to the top and are also removed. Treated water is drained off, leaving behind the settled material now called the preliminary sludge. Doesn't sound kind of gross. Secondary treatment. The secondary treatment starts in the aeration tank. Organic materials are broken down by microorganisms into carbon dioxide and water. Air is pumped into the tank to provide an oxygen-rich environment in order to further enhance the aerobic decomposition. Finally, for the tertiary treatment. Although most of the organic matter is broken down by now by microorganisms in the secondary treatment, there's still tons of harmful substances such as viruses, heavy metals, phosphorus, nitrogen, which can be present in the solution. Some ways of addressing this is the introduction of salts. Salts can be added to the solution. These salts are soluble and dissolve, and the cations react to form hydroxide salts. These hydroxides are insoluble, so they form a participate, or called floc in this case, that coagulates with the solids and drags them to the bottom of the tank. This sedimentation forms a heavy secondary sludge that settles out over time once more due to gravity. Afterwards, disinfection follows, introduction of a bunch of chemicals, and then the process of purification is effectively complete. That's all I have right now. Thank you for watching my presentation.